Bob Saget. What? That's weird to say. All right, so again, our objective today, 3 big things. Can we find the distance between 2 points? Can we find the midpoint? And then we're going to be talking about some circles. We're going to be talking about circles and their formula. So, yeah. You guys already got these down, yeah? Yeah. Oh, it's so hard for me to see you guys with hats on. I know you guys can wear them today. You guys can wear them today, it's fine. It's just, the general rule is you can't wear hats, so it's like, okay. Here is the distance formula. I think everybody's seen that, right, at this point?
Yeah.
It's horrible.
Are you going to show us a simpler way to do this?
Oh, if you want me to.
Yes. Well, is there like a different formula?
Whoever invented the distance formula, no, it's not dumb, but in my opinion, was like, got credit for just doing algebra. Because all that really is Pythagoras theorem.
Wait.
And I'd rather do Pythagoras theorem any day than to plug into this beast. A squared plus b squared equals?
C squared.
Okay. There are people that do love formulas, a good formula, so we'll do it that way, and then I'll show you guys how to do it repeat that way, okay?
Don't like distance formula.
You don't like the distance formula?
We did it last year and I hated it.
I hate it. Can I change the slide?
Yeah.
Great. I can change the slide?
Yep.
In the back? Alright, here we go. So, they want us to find the distance between these points. Now, using the formula, because I need to show you that, so that you don't say, you didn't show me the formula. You're just plugging values right in. So we'll call this set 2. We'll call this set 1 just to be consistent with, it doesn't really matter. If you want to swap them, you can. But, because I like to go left to right, and it goes 2, 1 minus 2, 1, right? So I'm just going to go 2, 1. So looking at the x's, I've got -1, and I'm going to take away from that a 2 squared plus the y's, so now -3 minus 3 squared. And then I'm just going to clean this up. So I've got -3 squared is 9. -3 minus 3 is 6. 6 squared is 36. So the distance is the square root of 45. Can that be simplified? Sure can. So this becomes 3 radical 5. Why? That's easy. It's fun. I'd rather look at 3 radical. Grr! Grr!
Do you know if math lab will take square root 45? Or do you go to 1?
No, it will always want simplest form. So 3 radical 5. Okay? Everyone okay with the formula? Just plug and chug, right?
Yeah, it's not
Just
that hard.
plug and chug, man. Plug and chug. That was our last year thing, huh? Can I change the slide?
Yeah.
All right. Let's go back. Let's go back to here. I'm going to clear this up. Somebody give me some coordinates, please.
3 and 6.
3 comma 6.
And then -1.
Say that one more time.
-1 and -5.
Okay. If you take a look at the distance formula, you're looking for distances, right? Because you're going to end up doing that hypotenuse bit. But all you're looking at is how far apart values really are. That hence the minus. So how far apart are 3 and -1? They're 4. How far apart are 6 and -5? 11, right? That'll give us c squared. So if you take a look, this we just did was all of this inside. That was all of the inside piece. 4 squared is 16 plus 121. That's c squared, right? Let me go ahead and add those up real quick. What is that? 137? That's gross. But then we go, to get rid of the square, we square root, right? And that's where the big square root comes from, this one. Woo! So there's c right there. Square root of 137. I don't think that can be simplified. But that's all that's really happening, peeps. That is all that's really happening. Okay?
Well, let me just use that.
Yeah, you can just use that. Just don't mess up.
Alright.
Just don't mess up. Questions? Ask me questions. Ask me a question. No,
How's your day?
not any question, math.
Oh.
Questions on this? Somebody ask me a question on this. Nobody? Going once, going twice? 3 times a day. Get off your cell phone. Alright, cool. So let's see here. Alright, so midpoint. Midpoint is just as easy. If I want to know what's in the middle of two things, I find their average, don't I?
Yeah.
That's what we're going to do. So we're going to find the middle of x's and then the middle of the y's. So for example, right here, I've got 1 and 7. What's 1 plus 7?
8.
What's the average?
4.
It's going to end up being 4, isn't it? Because 1 plus 7 is 8, divided by 2 is 4. 1 plus a negative 3 is? Negative 1. Divide that by 2. Boom. Boom.
Wait.
Do it again.
It's 2 and negative 3.
All right, let's do this.
Yeah.
This is my second set. This is my first set. Okay, so the second x. That's not an x. Second x.
Oh my goodness.
The second x plus the second.
X.
The first x plus the second x. Ah,
Wait, no, go take breathe.
I can't do it this way. It's so hard. Okay,
Do what you go.
we'll go in order of the formula. We'll call this 1. We'll call this 2. So all I'm doing is adding the 2 x's, right? So 1 plus 7, and then I'm going to divide by 2. Then I'm going to add the 2 y's. Okay, so 2 plus a negative 3, and then divide by 2. So that is 8 over 2, negative 1 over 2, which becomes 4 comma negative 1/2. Okay? Oh, that's so hard.
Math is hard. I thought math wasn't hard. That was good.
The formula's harder. I did it without any of that. No, the formulas. I don't know. I guess I've been doing it too long. You got it? So are we good with distance and midpoint formula?
Yeah.
Go back to what? The formula? There it is. Add the x's. No, not this one. Okay, next. Last, before that one. This one? Oh, that's when I did my shortcut? It's not really a shortcut, it's just I did some of the math in my base.
Is that really it? Wait, that's it? That's it? I'm fine with that.
Someone asked me to go back. We gotta do circles.
Oh.
We got to do circles.
Wait, like knowing like the degree of them?
I really hope not, because I hate that.
I loved that. I don't know why. I loved that. I don't remember that, but I liked it.
I don't remember that. I thought you were watching the drawing. That was the last thing we learned last week.
You're good? Alright, let's see here. Let's see how I'm gonna do this next. What slide is that? 6. Okay. I'm gonna do this a little differently. Actually, I like to do this. What shape is that? Ugh.
That's
Not too bad. What shape is that? It's a circle. Right in the middle lives something called the dot. The center.
That's not in the center. Origin.
It isn't the center from my angle.
Not from mine. That's pretty lopsided. Yeah, that is so bad. Can I draw the circle? I'm really good at it.
Oh,
Okay. Just hey. Just kidding. That's not in the middle.
close enough?
No.
Whatever. The distance from center to a point on the outside is called a radius. So we okay with all that vocab so far? We've got a center.
Is it going to be on the test?
Probably.
I swear if it is,
Give us
I will
hints.
literally walk out.
Yes. All right. Anyways, so let's do that. Let's do that one more time here. Got a circle.
Perfect.
Okay. So let's go from here to here. What's this distance called? Radius. There's a relationship. There's a relationship.
What? Who knew?
I'm just being nosy and listening to the side conversations.
Oh. I was like, are you okay? Because you're like your eyebrows just like went in. I was like, what are you doing?
If. What happened?
You know, you kind of remind me of. I can't remember the character's name, but it's from The Nightmare Before Christmas. I think it's
Okay.
a little boy.
Everyone knows we can do that, right? With a point, we can come down, find an x value. We can find a y value for that. Correcto? What do we call this distance here? No, that's not. Obviously, if it's a diameter, it goes all the way across, doesn't it? But we call that distance x. What do we call the vertical distance there? We call it y. So if we wanted to find a relationship here, anybody can think of one? Starts with a P, ends with an agorist. Yeah, there's another Pythagoras relationship, right? I can say that x squared plus y squared should equal r squared. Anybody recognize that? It's the formula for a circle.
Oh my goodness!
Wow, that just like takes out all the mystery, right, out of the formula. But yes, if you see a formula where they got x squared plus y squared, you're probably looking at the circle. And if it's minus, then it's going to be a hyperbola. 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 Yes, sir?
For that equation,
Mm-hmm.
isn't there like x plus 1 or x minus?
Well,
x?
let me get done, okay?
Okay.
So right now,
Sorry.
what formula you're looking at is a formula for a circle that's centered at the origin. Make sense? So, if I had,
Oh no.
that would be 0, 0 right here, right?
Oh.
Everyone cool with that?
That's the center.
Imagine it is, okay?
I can't. I'm asking you a question. I don't know. I'm not asking you to redo it. I'm asking.
I'm doing this for Elise because she's going to drive me crazy.
Gosh. She's like, I'm so bad.
Okay, so,
All right.
let's go like right about,
That's perfect.
no it's not. It's off as well. But anyways, so here we have a circle that's centered at the origin. If we wanted to find its equation, well, it's going to be that whole business, x squared plus y squared. And in this case, what's our radius? Looks like 5 almost. It's approximately 5, but there you go. That's how you write the formula, right? No. What should that be? Which is? Good. All right. So, woken up.
Trick me like
So, I love to do that. We're okay with this formula?
Yes.
Okay. What Ernie was saying is sometimes circles don't always appear where their center is at the origin. It just doesn't, right? Sometimes we want to take that circle and maybe we want to move it here, or here, or here, anywhere, right? So here's what I want to do. I need to tell me if it's right about there. Anise, would you be satisfied?
Yes.
Okay. So now I have a circle. I got a little dot there because we want to focus on that point as well, okay? So let's say we put our circle here. Okay? No, not there. Let's go here. Okay? Just like when we had parabolas back then, when we would move them, we had h and k, right? Move up, down, left, right. Okay? The formula would look like this. It was y is equal to x minus h squared plus k. Correcto? Okay. For our formula for circles, it's going to look like this. It's going to be x minus h squared, but because we have y on the same side, it's going to be plus y minus k squared is equal to r squared. So here's your generic formula for any circle. Okay. Now, let's make our formula for that one we just moved or transformed. Okay? How many units did I move to the left? Okay, from here I went 1, 2, 3, 4. That's a negative 4, right? So x minus a negative 4 squared, x minus a negative 4 squared. Now let's take a look at the y piece. How many units did I move up on the y? 2. That's a plus 2, right? And we still have a radius of 25? Cool. So here we go. So that means that the formula to this new circle is x plus 4 squared plus y minus 2 squared is 25. Ask me questions. Ask me some questions. Ernie Cipriano.
Is this for like the distance?
No, this is for circles. That's the formula for a circle.
So for like circumference?
No, for the whole thing.
Oh, for like the whole thing?
Yeah.
The area?
No, just the formula for the circle. Kind of like, remember when you used to do this? Hey, graph me y equals 3x plus 2.
Yeah.
That's enough information for me to graph the line, correct?
Oh, yeah.
Well, I'm giving you all the information you need to graph the circle that I have.
What is that variable?
Which variable? Y?
Next to y and this down.
Oh, that's a K.
Okay.
It's an ugly K. But it's okay.
I got you. Sorry.
You guys cool with that? Ask me questions. No questions, Mika? It's too easy. This is so easy. All right, let's see what slides we had saved up. Okay, here we go. I need to write the equation of a circle. Its centers at 0, negative 6 and has a radius of 10. So, I start with my x. Was there any movement, left or right? So that's going to stay x squared. Was there movement up or down?
Yes.
Yes. So this is going to become a plus 6. And my radius is? Or sorry, not my radius, but the equal part would be 100. Yeah? Ask me questions?
Where'd you get the 6 from? I'm kidding.
Oh, 2. Ask me a question, Adriana.
Why does it have to be the opposite sign?
I'm going to give you my explanation, which makes sense to me, okay? Makes sense to me. And I think I talked about it with a, let's see if I can make this work. How do I word this for you? Do you remember when we used to have intercepts back then? Like, let's say this intercept is at 1, and we'll call this intercept at 3. Okay? So think about it kind of like this, okay? I know I could get an equation for this parabola, correct? It would read y is equal to x squared plus 2. We're just making stuff up here, okay? Obviously it's not, but we're going to say it is. Now, this is an equation, correct? But I also know that in this case, we're looking at this one, that I have an intercept at x equals 3, correct? And I want to tell the reader of my equation that the x-intercept is 3. Can I take an equation and plug an equation into it? No, that looks ridiculous, doesn't it? And it doesn't make any sense. But I can provide the same information. If I did this. I said, okay, I'm going to subtract 3 to both sides, which means that x minus 3 is equal to 0. And I know that when x is 0, I've got an intercept, don't I? So I can take this business and plug it in and still express the same idea. So that's not an equation, but because of the algebra involved, we end up having the opposite effect, if you will. Does that help? Cool beans. So when we look at this, we're taking intercepts and we're trying to plug them into equations. So we kind of end up showing the opposite of what's really happening. Now, we don't have that problem with the y-intercept because it's outside, right? When it's a parabola, it's outside. So we know that if we make x 0, this all kind of goes away, and we get a y equals, so it's not so bad over there. So, okay? Sketch this, guys? Go for it.
Time to peek in the dojo.
Adriana R. Is that you, Queenie? Where? I guess that's me. So, Adriana, tell me where the center of this new circle is at. Give me the coordinate, please. X comma Y. Negative 3. 1. Can I get a second and a third? Ooh, got a bunch of them. Good. So, I'm going to go 1, 2, 3, 1. There's my center. Okay? Next. Let's see what the dojo says. Yahtzee. Yahtzee. How far out do I need to go? So I go 1, 2, 1, 2, 1, 2, 1, 2, and then try to connect those as best as you can with a circle.
I'm just kidding.
Cool? Just do it.
How many more slides do we have?
A bajillion.
One laugh that was.
Can I change the slide?
Yes.
Yeah.
Yeah. I'm so sweaty.
What?
What was that?
That's the same thing. That's the same thing.
Sound effect.
That's the same thing too.
Oh, here's a general form of a circle. It's very bleh.
That's very good.
Go ahead and write it down, please. What? That is a general form for a circle.
I don't know what that means.
Ask me questions?
Yes.
Yes?
Are we done?
No.
Why is math hard?
Where are we gonna get D and E and F?
Those would be coefficients that we get from the shifts Yes, I can.
Is that the pretty much taking the equation apart?
Yeah, that's pretty much taking the equation. So you know how you have x plus something squared?
So like
You
just
FOIL that out, and then you take the other one, and you FOIL that out, and then you combine everything, and make sure you move everything to one side. That's all that really happened. So, yeah.
Why did they do that?
Well, hold on. Because that's how they're going to give you a circle. They're not going to give it to you in the standard form.
Wait a minute.
They're going to give it to you in the not so nice form. What's this?
General.
The general. So they give you general form, and then you're going to want to write it in standard form.
Wait,
But why
go
would
back
you
to
even
the
make
first
that?
slide again.
If the general formula.
Because that's what we use generally.
Okay, then what's the point of standard form? I don't like it.
Because standard form is easier to see. You can clearly see how much up, how much left, how much right,
Why would they even make that?
and what my radius is. What's up? Go back to the first slide.
Slide before this.
The formula one?
Yeah.
Okay.
So, question.
Yeah.
Your EY is positive in the whole general equation,
Uh-huh.
but go down to your example. Oh, I did it. Why is it a negative for Y?
Because it can be. You can always add a negative. You can always add a negative. I'm over it. So let me show you what's going to happen, okay? The question was here, everything is positive, right? Plus, 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 plus. But those are just general ideas. You can always add negative values. So it doesn't mean that D, E, F can't be negative as long as they are real numbers. Okay? All right. So, you guys ready to see this? This is going to be like...
Oh, we're not done.
No! We got to take this
Oh my gosh. I thought
and convert it to the
general form?
standard form. This is general.
I didn't see standard form.
Yeah, you did. I showed it to you. That's the x squared plus y squared equals... Oh, you were. My bad. All right. You guys ready? Please watch. Me, not your cell phones. Watch me. Watch me. Ooh.
Oh my goodness.
Don't be it.
Are you live right now?
I like how Tyler looks
yeah.
back at his phone.
I already know.
Any questions on what I've done so far?
Yes.
Why is there a space?
Oh,
Oh,
wait,
you
that's
have
supposed
to
to be a
complete the
Y.
square.
Oh, I don't have to do
Oh,
no,
thank you.
never mind, never
This
mind.
is supposed to be a y. Thanks.
Yeah, okay.
Okay? Because I want to go to standard form, here's what I'm going to have to do. And hopefully you picked this up last year. I'm going to do something called completing the square.
Oh. What?
I hate
Oh my.
Whoa, 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 whoa. That hurts a little.
I've heard that.
Okay, Ernie, watch out. To complete the square, I'm going to take half of this middle term,
Oh, so it's
and then I'm going to square it and throw it back in here, which is 4. That 4 wasn't there, so I want to make sure I throw a 4 on the other side in order to keep this all balanced out, right?
Yeah.
Everyone cool there?
Yeah. Why?
Why what?
I don't understand. Who came up with this?
Seriously, why?
Some mathematicians with very long curly hair.
AKA overdose.
Okay? Now, going on to the other part, plus, let's do the y's. Square root of that. What's half of negative 4?
Negative 2.
Square that.
It's positive.
It's going to give you a positive 4. So I'm going to throw another 4 on this side to keep it all balanced out. This is going to equal 9. And there it is.
That's
You're
the
done.
end of it?
wow.
Yeah.
Hold up. Hold on.
Wait, so you don't have to square it?
That's pretty.
No, it's already done in that form. What's my radius?
3.
Good. It's 3. What? I didn't catch that.
So you get it, but you don't get it.
Oh, this is so difficult.
It's not.
Do you guys remember when you were completing the square?
Yeah.
Do you ever think you'd have to do it twice in the same problem?
No.
You just did.
What?
And Parker. Next problem.
No, now we just need to figure out where the center is at. Where's the center at? Negative 2, comma 2. What's my radius? And if I were going to sketch it, then
Wait, why is it negative 2? Why is the x? Wait, why is the x negative 2? Oh, never mind. Never mind. Never mind. I just answered my own question. Answered my own question. 2 and 2 is 4.
So something like that.
Yeah.
Blech. Blech.
It's fine.
But there you go.
Onions flavor.
Hey, you guys.
This is Goonies.
We're done.
That's it.
Woo!
Unless you have questions for me, ask me a question.
No.
Ask me questions.
I don't have
Ask me
questions.
Go ahead.
Why does math suck?
Yeah, so I took half of this piece. That's just completely the square. Half of this, and I square it, throw it back up here, and then try to balance it out again. Okay. Half of -4 is -2.
We need to
Right now, as soon as we get done.
The retweeter.
All right. Yes, you will. Ask me questions. No. I'm gonna call. You know what I'm gonna do? I'm gonna have the dojo call you, and then I'm like, you ask me questions.